the mathematical way. I'm trying to avoid that mathematical approach since we know already work point chapter, we know spring block system. No, directly let me jump to the spring block idea, that one. So this is the spring and here is a block. Okay, this particular position is called like a mean position. We'll call this as a mean. This vertical line is called as a mean, and this is a wall. Okay, I'll give velocity to this at mean position. I'll give some push. Sir, how to give push? Go back, impulse, you know impulse. So can I apply some impulse? Yes, I'll apply some impulse to the block. So it will start accelerating. So when it comes to this position, what is the state of block? We know spring force will be acting here. Go back, work point G chapter. You know, I told you, I think, can you remember? I told you, what all you study spring block system, you are going to come across a chapter called like a simple harmonic motion where the 80% of numericals are based on spring block system. So if you know just the idea of spring energy, work done by spring force, potential in the spring, that is enough. You can see just, I think today, you open the material or any of the book, where all you see the spring block only. Vertical spring block, horizontal spring block. So how much you know about the springs, the more safer. So what I suggest today, half an hour at least, you recollect all the spring problems, what all I discussed. Just don't solve. Just only go through them. Just see them. Vertical spring block, horizontal spring block system. Just only see them. Then what when as you enter, no, the background will be there for you. Fine. So you have to recollect all that spring block systems, what all we have done. Not solving. I'm not asking you to solve. Just plainly read them. Just see them. Okay, yeah, like this is a thing. Don't take pen. Just only. Unless and come to this chapter. So the block will be here. So here, what are the things like it will have spring force will act. I'll show it. What about the velocity of the block? Will be like this. Will there be any acceleration? Yes, the acceleration will be in this direction. Let me call this is A1, V1 here. So what will happen to the block? Block definitely will undergo retardation. Look at the spring force acting opposite to velocity. So after some time, the block will be at right extreme. And what is the state of it? Instantaneous rest. So here the maximum spring force will be acting. And that will call K. This is called like a amplitude. Upper extreme, this point is. If you say that, sir, we already know this, then it's quite very easier. Okay, now block again, what happen will accelerate. So somewhere let me take this position near to the main position. So in what direction spring force will be acting? Towards left. The speed of the object will be like this, and how the acceleration will be directed towards right. So there you took X and Y, doesn't matter. By the time again block comes to mean position. So this is the mean position. So what is the spring force? Will be 0. The block will have maximum speed and acceleration will be in fact 0. Then because of this maximum speed, what will happen to the block? It will start compresses the spring. Then how the spring force will act? Spring force will act in this direction. Kx3. The velocity will be v3, a3. Very next position, it will come to extreme and will come to instantaneous rest. This will call as, sorry, this is right extreme. This called as left extreme. And maximum spring force, spring is compressed, no? So this is K. Okay, we'll write. Then how the acceleration will be directed like this. Instantaneous rest it is. So what is the next state of the block? The block will be somewhere here. Spring force will be acting. Kx4, B4, A4. And the block will return back to, I think we have space. Yeah. Mean position. Actually, if a good teacher is there, since you know to and from motion in spring block, that is what SHM. He will send, you'll start numerical. I need not to discuss all. Okay, again, the mean position. Again, the block what happened will continue its motion. Okay, further again, same thing. What was the V1 we took it, no? I'll show complete description. See once, huh? It'll be. Now, what is the state of this block? Instantaneous rest. Shall I write IR? What do you mean by R? Instantaneous rest. Very, very, very important. Already we know this. Once again, we are putting, because what is the problem? Poor memory. What all we read, we'll forget. That is our natural phenomena. So if you show interest, you'll not forget. Just for sake of rank you're reading, things will be like this one, will forget. To gain knowledge when you read, no, then nothing. Everything what you'll enjoy and you'll never forget. How you forget movie? Possible movie. Am I right? Take example of your practical life. You ask me some movie which I was in 12th standard. I do tell. I do tell that one. Okay, what is the movie which I saw in 12th standard? DDLJ, Dilwale Dulhaniya Le Jayenge, super hit movie. You ask me, okay, I'll tell all songs, everything. But same thing, 12th standard, what all my teacher taught, even I too cannot remember everything. What is the problem? The movie, I was very much interested. I loved it. The knowledge that was imparted by my teacher, what happened, it was like forcibly I was accepting it. So I could not remember. What is the memory? There's the only thing, memory. Science, what happened? See, we are in a scientific world. Everything is well defined. Everything is in scientific. That one. In science, what happened? We define memory. What is the memory? The one which you are interested, and if you love it, if you by heart you like it personally, it'll become memory. The one which you don't like it, it'll not be a memory. Some asked me, sir, I'm forgetting. Finish over. This is only the reason. It will hurt you, but there's a reality. Okay, you can experiment with your the real life situations. Some will forget, some will remember like as it is. There's the only reason. So what is another thing? The one which will have psychological impact, it will be a good memory. The movies, what happened, what we watch, no, they have psychological impact on us, a deep impact. That's why we are able to remember. So this is what also, that's why I asked you to draw a diagram, imagine, because they will show some psychological impact and it become very easy to remember. There's the only purpose of drawing diagram. Otherwise, in textbook, what we have? Question, answer, equations, question, answer. We'll forget. Through diagrams, what happen? It'll become memory. That's the only purpose of why your physics teacher is drawing so many diagrams, so that it'll be easy for you to remember. But still, sir, I'm not remembering it. Something, it is not showing psychological impact on your brain. Please do analyze. You have very good brain with you. So you should know how to utilize, that's all. All are having same potential. That's what I feel. Myself and any scientist having same brain, Scientists used it very perfectly and efficiently. They became scientists. I could not use, I became teacher. And what is the difference between your teacher and you? Your teacher is using to some extent better than a student. That's why he's teaching. Students are unable to use properly. That's why they're student. That's why they're struggling. Okay, got this? So what is the problem now? Its problem is with us, not with anybody. Not getting marks. You are the problem. He is getting marks. Yes, he has overcome his problems. The more and more make observation of yourself, the better things what happen. You are going to improve yourself. Okay, let's come back. Huh? Okay, now look at this one. I gave velocity, so it will undergo retardation. Why it will undergo retardation? Spring will get elongated. Spring force does negative work. So here, in what form the energy was? The energy was in the form of kinetic energy. Kinetic energy was maximum. What about potential energy? Zero or minimum. You can put anything. Minimum. Shall I all of you able to see? Because I had to show complete description. No, that's why I just zoom in. I made. I think I'll continue with this screen only. Okay, next part. Okay, come for this one. What about here? It's having kinetic energy and also the potential energy. Will I agree? Both are. What about here? Instantaneous rest, IR. IR means instantaneous rest. So instantaneous rest means, what does it mean? Kinetic energy will be zero and potential energy will be maximum. What about here? Both are non-zero. Here potential energy is minimum. If you want, if you write zero also better, let's write minimum. Minimum zero or minimum. Here both are non-zero. What about here? Left extreme, potential energy is maximum. Instantaneous rest, no? So kinetic energy will be zero. Both are non-zero. Kinetic energy maximum, potential energy, and both are non-zero. Like that, you leave this block, what will happen? It will continue its to and fro motion if there are no any resistive forces, no friction, no viscous rate drag. What happened to this block? Forever, forever it is going to continue its to and fro motion. This is what the SHMI say. Sir, how do you can say? Okay, I'll go back to the same mathematics what I have. Okay, look at this particular block here. So what is the retardation? Kx equal to minus me. Kx equal to minus me. And look at that acceleration. That x varies harmonically. So how do you can say? Okay, I'll take help of the energy equation. You may not agree with this. Okay, let me start with energy. In what form energy is here? Both potential plus kinetic. The total energy U plus K. Now, what about potential energy? K x square by 2. What about kinetic energy? Kinetic energy Ke, I'll write it because I'll be using spring constant. So some of you are asking, sir, spring constant? Huh? No, spring constant. Why I'll write nearby U? Okay, no. What is kinetic energy of the block at any position of mv square? What is the total mechanical energy? Total mechanical energy. Now, you know in workbench chapter, I'll give velocity to the block at mean position. When it arrives here, the same mechanical engine what was given is available as kinetic engine, potential engine. So what happened to overall mechanical engine, spring block system? Will conserve, mechanical engine will be conserved. The reason for that, spring force is what? A conservative force. Go back all the concepts. Conservation of mechanical engine principle is what I'm writing. The total mechanical energy imparted to the block at mean position equal to the total mechanical energy of block at any position. This one. So this is a constant. I'll differentiate. So k by 2, this will be 2x dx by dt. M by 2, 2v dv by dt. Total mechanical energy will remain constant. What is E? Shall we call total mechanical energy imparted at mean position. You can impart anywhere. I started with simple situation at mean position. Total mechanical energy imparted to and it will remain constant. That but energy, what happened? What we given kinetic energy may not be only kinetic energy here. Some part will be kinetic energy, some will be potential. Now the whole kinetic energy given is available here in what form? Potential energy. Able to understand now? So this will be, so I'll put 0. So this will become kx v plus mve. So a equal to minus kx by m. Let me compare with this equation, omega square x. From where I brought it? Acceleration proportional to negative of displacement. So therefore, what is this omega? Root of k by m. What is this omega? Omega is the angular frequency. We can write one more very important conclusion. What is that? Time period. I brought time period. So you can ask questions of why you brought time period again. Suddenly you started something and you ended up time period. Okay, let's do one thing. What is this T? Time period of